Hello and welcome everyone to today's webinar on improving control over Kubernetes operational software, related apps, and access management at scale. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to demo how you can add fine-grained pod level access controls for enhanced security and the key use cases that benefit. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OCI. To access the promo, please sign up using the same email that you registered with for today's event. We'll also be recording this session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called OKE New Features that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the demo. Today's webcast will be presented by Jeevan Joseph, Senior Principal Product Manager, Mickey Boxall, Principal Product Manager, and Rishi Johari, Principal Product Manager. So without further ado, I will hand it off to Jeevan.
Thank you, Tara. So welcome to this talk on how to improve your control over Kubernetes operational software and access management and related applications. We're going to talk about a whole bunch of new features that we've added to the OKE product and how that helps you, manage your cluster in a much more efficient and easy and more approachable manner and at scale. So without further ado, let me get right into it. Let's start off with the safe harbor statement because we're going to make some forward-looking statements. And the rough agenda for today is, I'll give you a brief overview about, OKE if this is the first time you are, seeing or hearing about OKE. And Mickey will follow up with some feature highlights and a demo, and Rishi's going to follow up with more features and demos, right? And we'll close with a Q&A session at the end of the session. Okay. So, broadly speaking, like here at OCI, we have a whole swath of services that are targeted for the cloud native application developer, right? So everything that offers, a lot of control by running your own Kubernetes control planes if you want, to support for the Kubernetes standard cluster API, to our managed Kubernetes product, which is OKE, which is a managed Kubernetes product and our flagship product in this lineup. Recently we also announced virtual nodes, which is a serverless experience for Kubernetes, where you do not have to do any kind of resource management. Even the data plane and the control plane is fully abstracted. You could use standard Kubernetes tooling, standard Kubernetes manifests to deploy your applications without ever having to worry about infrastructure. We also have container instances and functions, which are also, which are both, serverless offerings. So as you can see, our strategy when it comes to cloud native application development and cloud native platforms in general is to offer the maximum amount of runtime flexibility. So we want to meet customers where they are. If you are the type of customer that have a lot of customization done to your Kubernetes installation, and you're running customized control plane components, right? We have an offering for you. Right? If you are, like the vast majority of Kubernetes users that use a managed Kubernetes to offload the control plane management, the high availability features for the control plane, management of the etcd cluster, all of that to a cloud provider, but you still want to retain control over your data plane nodes, the nodes on which you run your applications, you want to customize it, you want to add additional software on it, endpoint security, all of that, we OKE can do that for you, right? As you move through the spectrum, you will see that, you're trading off more agility or more control, right? So regardless of where in the spectrum you fall, chances are that, OCI has a platform that will suit your needs just right. And today's talk is going to focus on our managed Kubernetes service at OCI called OKE, or Oracle Container Engine for Kubernetes, right? The main goal for OKE Container Engine for Kubernetes, or OKE, is to reduce operational burden, to make sure that you have the runtime flexibility, to give you like sensible, safe defaults that give you a really strong security posture right out of the gate. To operate on top of like OCI's Gen 2 cloud infrastructure, which gives you several cost advantages, right? And all of this results in your ability to lower your TCO, to accelerate adoption, and to improve your time to market, right? And over the past couple of years, like I've been noticing these CNCF surveys that they do every year and publish on the CNCF website. And like consistently, like training and security has been identified as a key blocker in the adoption of Kubernetes or cloud native technologies at large enterprises. And, this is one of the areas that we want to, take on with OK, right? Because right out of the gate, you're going to get safe defaults. You're going to get a very strong security posture. And we want to make the service as approachable as possible, right? We want to automate more things on the service for you, so that it becomes very easy to get started with, and and it's not just about getting started. We want to make sure that the service is very easy to operate at scale even after you get started, right? Because usually platforms that are very easy to get started, kind of like, use kid gloves, like I like to say. And what that generally means is that they're going to abstract a lot of features from you. So, while it's great to get started with, it is not really great to run, like massive applications at scale, right? Because so many controls have been abstracted away from you, right? And this is where OK kind of strikes a balance where, we give you the control when you need it, and you have the option of, offloading a lot of that to the cloud provider as well. So again, the main benefits and the point behind OK is, first of all, we are centered around open standards, right? So this is not a fork of Kubernetes. This is upstream Kubernetes, right? It is certified Kubernetes compliant. There is no vendor lock-in. So if you're using standard Kubernetes manifest, either on-prem or with another cloud service provider, you can very easily bring those manifests as is to OK. And, like our container registry and all our underlying stack is built on top of open standards, right? We offer built-in management, and, like as a managed Kubernetes service, like we try to make it very easy and approachable in the sense that, our offering is always highly available. Our offering is always a fail-safe. It offers a secure control plane that is fully managed, always highly available, and like things like upgrades are managed without any downtime to the end users workloads, right? We are again built on top of OCI's compute infrastructure. That means that you can get one of the best price performance ratios, which is at least 3 times better than the industry average, right? And what that enables you to do is also like, you also get access to the flexible and innovative features that we have on the compute front, right? So you have access to things like flex shapes, right? So you could create like a 7-core machine if you wanted to, and use that, because if that's the right size for your workload, we shouldn't be like forcing you into an 8-core or a 16-core type machine, right? Either because you wanted the extra memory or you wanted the extra cores. All of that is flexible. And, like I mentioned earlier, OCI has proven itself to be one of the most reliable clouds out there. And, like built on top of OCI, like we also inherit that. And very recently, we also announced a new set of features that we are calling enhanced clusters, which also brings a financially backed, service level agreement, NSLA, to OK. Right. So, when you use enhanced clusters, we give you a financially backed SLA that kind of shows that the reliability and maturity of the service. Right. we have support for advanced security within OK. Like you can integrate third-party security tools because we are based on open standards. But again, right out of the gate, you're going to get a lot of security integration with OCI IAM, federated identities, SSO providers, and all of that right out of the gate, right? OK also integrates with a whole swath of other services inside of OCI. Like for instance, DevOps, right, which has built-in strategies to deploy applications to OK. Like you could with the click of a button, you could implement blue-green deployments or canary deployments, which is supported natively inside the DevOps service. So that's like one type of integration, right? We also integrate with other services inside OCI, like file storage systems or FSS, where we can dynamically provision FSS mount targets and other resources for you, or the load balancer service, or the network load balancer service, or IAM, or other services inside OCI, right? And again, when it comes to extensibility, out of the gate, we support the standard Kubernetes extension mechanisms, and we offer a lot of extended capabilities as well, right? For instance, the service operator for Kubernetes brings a lot of OCI services as Kubernetes managed resources, right? So if you wanted to create an object storage bucket, you could write a Kubernetes YAML to create and manage your object storage bucket inside OCI. We also offer a database operator, right, that can create and manage autonomous databases on OCI, or even sharded databases that are completely inside your cluster, right? So all of these resource management kind of becomes your, you can start managing your resources through Kubernetes, right, in a very cloud native fashion. And the same goes for we also offer a WebLogic operator which you can use to deploy your WebLogic domains and WebLogic applications onto a Kubernetes cluster like OKE, and automatically take advantage of Kubernetes features like automatic scaling, horizontal pod auto scaling, cluster auto scaling, and other features, right? So that kind of sets the stage for all the features that we're going to talk about. So let me hand over to Mickey to talk about the features that we're going to dive into more detail and demo today. Mickey?
Sounds good. Thank you, Jeevan. So we're going to segue into new features and demos. So to begin with, I want to talk about Add-on Lifecycle Management. So this is one of the new features that's available through enhanced clusters. And Add-on Lifecycle Management is pretty cool because, as Jeevan mentioned, we're kind of taking off the kid gloves. When you provision an Oracle Container Engine for Kubernetes cluster, even if you don't deploy any pods yourself, you'll find that there are a number of pods, essential software pods, running in the kube system namespace. So for example, if you were to run kubectl pods on the kube system namespace on a brand new cluster, you'll see kube proxy running, you'll see CoreDNS running, and you'll see your CNI running as well. Previously, the way that it worked is if you made any customizations to these, maybe you wanted to update kube proxy or pass in a change to CoreDNS, we would overwrite those changes. We would have a reconciliation loop that would go through and overwrite it because this is essential software required for the cluster to run correctly. What we're introducing with Add-on Lifecycle Management is two things. One, we're for the first time allowing users to make customizations to those add-ons. So for example, you can update the CoreDNS core file via a config map and make other changes without us overwriting those changes. And so that's very powerful because it gives our users more control over the operational software running in their cluster. Also, previously, all of this software had a fully managed lifecycle, which meant that you didn't have to do anything and it would continue to be updated as new versions released, or when you upgraded your cluster, the add-on would be upgraded as well. And all of that is still available for users to opt into, but it's also for the first time available for users to opt out of. So what that means is, perhaps you have some sort of corporate requirement, some compliance standard where you can't let a third party modify any software running in your cluster. Well, for the first time, you can opt out of us doing that. So this is very powerful for people with those very strict requirements. On the flip side, Add-on Lifecycle Management is also very cool because it provides users access to more than just those essential add-ons. So as I mentioned previously, there were just these essential add-ons deployed to the cluster, kube-proxy, CoreDNS, your CNI, and those are the only pieces of software that had life cycles fully managed by Oracle. What we're adding with this is a growing portfolio of additional software, optional software you can deploy in the same manner and also have benefit from the same lifecycle management tools. So for the first time, you can click a single button and have the Oracle database operator deployed to your cluster, which then you can use to, as Jeevan mentioned, create a sharded database or connect to an on-premise database via ORDS or provision an OCI database cloud service. You can also have a Kubernetes dashboard automatically created for you. Same thing with certificate manager, WebLogic operator, and more that we're adding over time. And rather than, talk to you about this exclusively, I wanted to show you it as well. But one thing before I transition over is that in addition to being able to opt out of updates to the add-ons, you can actually opt out of the add-on entirely. So if you wanted to opt out of native pod networking or Flannel as your CNI and bring your own CNI like Calico, that's now an option to you as well. So again, kid gloves are off, and we're basically allowing users to do anything and everything they'd want to do with this operational software that previously they didn't really have access to. All right, so hopefully y'all can see my screen, and this is a live demo, so anything can happen. What I have here is a cluster that I created a few days ago on the 11th. And I'm just going to jump into this cluster and scroll down to the new add-ons resource. So this is just on my cluster details page. If I go down to the add-ons tab here and click add-ons, I can see the different add-ons that I have deployed to this cluster. If I wanted to change the add-ons that I have access to, I can simply click, oops, sorry about that. I'm going to jump into kubectl in just a second. I can simply click manage add-ons, and then I can see the different add-ons that are available to me and the different ways in which I can interact with them. So for example, I could go in, and if I really wanted to, I could click Flannel, which is my current container network interface, and I actually could go in and disable it altogether. Now, you'll see this warning pop up: disabling your CNI should not be done lightly. It's a pretty big change to make to a cluster. So in this case, I'm going to not do that, and instead I'll pick another add-on to interact with. You'll also see some other options here as well. So if I wanted to enable the Kubernetes dashboard, I see an option to enable the dashboard, but I can also choose between an automatic update or selecting a particular version. So here I'll see there's just one version available for my Kubernetes dashboard, and that's because I'm running on the most recent OKE Kubernetes version. And as such, there's only the newest version is compatible with this cluster version. I also have the option to add configurations as well. And this looks a little bit chunky right now because I have it zoomed in so everyone can see my screen. But if I wanted to, I can choose between a variety of key value pairs here, like number of replicas or node selectors or tolerations, all of which allow me to make customizations to my add-ons. So for example, choosing number of replicas and setting that to 1 allows me to just create a single replica of the database, the dashboard. Whereas I could also, if I wanted to, specify 2 or 3 or any number. I can use node selectors to select the nodes on which I want my add-on to be deployed, and the same thing for tolerations as well. So what I'll do here is click Save Changes, and saving changes will actually deploy the operator to my cluster. Excuse me, the dashboard to my cluster. So we'll see that it's enabled here. And if I want to have a detailed view of the process of it being created, I can jump to the work request section and then click the enable add-on work request to actually see the logs that are in place. So this looks like a pretty quick deployment. All I've done here is really just, seen the kubectl steps to actually deploy the add-on. And then if I want to see the add-on itself, let's jump into the console and connect to the cluster. Cool. So I can now see Kubernetes Dashboard was deployed to the kube system namespace about 35 seconds ago. So the cool thing is that that's about as easy as it is to deploy these add-ons. And again, you have access to both the essential add-ons that are already available in clusters today in order to make additional customizations to them. And also these optional add-ons like Cert Manager, like Kubernetes Dashboard, like the Oracle Database Operator, and more that we're adding over time. Cool. So that's what I wanted to share on the add-on front. We are going to have a question for you a little bit later on, talking about which add-ons you would like to see us add to this list. Because as the PM responsible for this, I would love to have more data points about which add-ons to prioritize moving forward. So another very cool feature that's part of enhanced clusters is on-demand node pool upgrades. And these are intended to simplify the process for upgrading and updating worker nodes, specifically managed worker nodes. You'll notice this is on the roadmap. This is actually marked for release next Tuesday, so people don't have to wait too long to get access to this. So the way that node upgrades work today and have worked for the last few years is that users will go in and they will change a parameter or a property of a node pool. These properties could be Kubernetes version, they could be image, shape, SSH key, node metadata. There's a whole lot of different properties available for users to modify. Now, these properties, which are at the node pool level, are inherited by all nodes within the node pool. Now, the one caveat is that when you make a change to those properties, nothing happens to the existing nodes in the pool. Those are only passed on to nodes created after the property was updated. So what does that mean? Well, that means that after you update those properties, it's actually your responsibility as the user to go in and replace all of the existing nodes with nodes running the upgraded properties. And this can actually be a bit of a pain. You know, there are circumstances where users might have a lot of node pools or a lot of nodes, and it can be very cumbersome to have to go in and terminate and replace all of those nodes, especially if they have workloads already running on them, and do so in a manner that takes into account availability and other best practices of keeping your workloads online. So what we've done is we've introduced a new cycle feature, a node pool cycling feature. Essentially, instead of having to do all of this manually or write your own custom orchestration, instead what you're going to be able to do is simply navigate to a node pool, update the properties at node pool. Again, it could be version, image, shape, or something else. And then after you click save changes on that, then you have an option to just simply cycle nodes. Now, one thing that's worth calling out is that as part of the node cycling process, your workloads have to have some space to shift from existing nodes onto new nodes, or the ability to shift from a node without space and a node that's being taken offline to a node that still has some space left to accommodate additional workloads. So following the best practices implemented by Kubernetes deployments, what we've done is provided users a couple of additional levers to pull as part of the upgrade process. So users can either apply max surge, which adds additional nodes to the pool for work to move from existing nodes to those new nodes, or max unavailable, which limits the number of concurrent nodes taken offline so that there's always a sort of low watermark of nodes available for your workloads to be scheduled onto. These are good options because max surge allows you to prevent downtime during your upgrade, because it'll always leave extra space for workloads to be scheduled. And max unavailable is a great way to do something similar, but in a way that doesn't require the cost of additional workloads being added to your cluster. Cool. So again, I'll segue back to the demo area. So in the same cluster that we looked at before, it's called node cycling, or NC, I'll jump into one of the node pools that I already have created. So in this case, my cluster is already a Kubernetes 1.25 cluster. It's up to date. We'll actually be releasing 1.26, I believe, next week. And what I want to do here is bring the node pool that I have up to the same version of my cluster control plane. So I have this node pool. I'm seeing a warning. I'm seeing an indication that I should upgrade to the latest version because this node pool is still running on 1.24.1. So I'll click on this node pool, which I've called Upgrade Me. And I'll make an edit to the node pool in order to change the Kubernetes version to the newest version. So right here, I'll change it from 1.24.1 to our current cluster version of 1.25.4. Changing the version here also changes the image, which is right here. So I can see that I'm using an OKE image, which is an image that's pre-built with all of the Kubernetes dependencies already on the image. And this image includes Kubernetes version 1.25.4, so I didn't need to do anything there. And finally, scrolling all the way down to the page, I'll see there's a new indication here, just reminding me that the updates to these node pool properties only apply to worker nodes created after I click Save Changes. And it also encourages me to click Cycle Nodes to apply those changes and replace existing nodes with nodes running updated properties. So I'll save my changes here. And this will trigger a quick update. If those with keen eyes will notice that the Kubernetes version of my node pool already changed from 1.25.1 to 1.24.1 to 1.25.4. And this node pool should just take a moment to update. I can track that update here. So node pool update has already succeeded. And this is just taking a moment to change. Yep, there we go. And then the next step is to apply those changes. So I can go here and actually trigger a node cycling. So for the sake of example, I'm going to select 1 as my max surge. So my node pool will scale up by 1. And I'm comfortable with 1 node being unavailable out of the typical desired number. So there are some caveats to the surge. You can't go more than double your current node pool count. So if you have 3 available nodes right now, which is what I do, I couldn't go to 4 because that's going to more than double my nodes, which is an odd activity if you're just trying to maintain a desired size. And similarly, I can't have more than the existing 3 nodes unavailable at the same time as well. You'll also notice that in order to accommodate different sizes of node pools, maybe you have 75 nodes in your node pool and you don't want to have to think about an integer value for the number offline. You can also instead pass in percentage. So maybe I'm comfortable with 10% of my nodes to be offline at one time. After choosing those values, I'll just simply click Cycle Nodes, and this will trigger my node cycling operation. So there are a couple ways that I can track this updated progress. One is I can jump down here, see work requests. I have a node pool cycling work request already in progress. And if I stay on this page, I can start tracking in more detail what exactly is being taken place on this node pool. So it's indicating the number of nodes that need to be cycled. And if I stay on here, I'll start seeing more logs related to how many nodes have been cycled, how many are left to be cycled. Yeah, here we go. So I'm launching 1 and I'm also terminating 1. And that's because I set max unavailable to 1 and set max surge to 1 as well. You can also see a status here. The other cool place to track your node pool cycling operation is to actually just look at the nodes themselves. Here we go. So back to tracking the nodes. This is the last thing I wanted to share related to this. The node cycling operation will take a couple minutes. It all really depends on what workloads you have on those nodes. And the reason for that is because node cycling takes into account the values that users have chosen for coordinate and drain options for their clusters, and also other things that are set at the Kubernetes API level, like pod disruption budgets. So for example, you can actually set the amount of time that you want to allow your workloads to be evicted from nodes running in your node pool, and node cycling recognizes that and will not terminate a node until those workloads have already been successfully evicted from the node. But the cool thing here is that you can see, our surge up and also our taking a node offline. So hopefully this made it pretty clear how node cycling worked. And if there are any additional questions, please feel free to ask in the chat. And with that, I will turn it back over to Rishi.
Okay. So as mentioned earlier by Jeevan, we contributing to our flexible container runtime story. we have recently announced the offering of virtual nodes. And what's been driving this is, based on annual CNCF surveys, complexity with managing nodes has been one of the top challenges users have reported. And even a lot of our top customers, both internal and external, have talked about how they want to simplify node management operations in the Kubernetes cluster data plane. Now, as you can see, OKE is a managed service. We manage the control plane for you, as you can see in the slide, for both virtual nodes and managed nodes. However, now with virtual nodes, OKE now fully manages the control plane and data plane. So how does this help our customers, right? It really reduces the operational burden now, right? So users do not have to provision or manage any of the nodes. So the resources needed to run your Kubernetes pods are abstracted away from the users. So users can fully focus on their applications and not infrastructure. Oracle is going to be responsible for repairing all the compute resources. And in addition, it really simplifies the Kubernetes operations. Oracle is going to be responsible for scaling your resources. So as part of this serverless Kubernetes experience, it really provides that capacity without worry for customers. So customers don't have to worry about under-provisioning or over-provisioning compute resources, estimating what they may need, right? That may cause provisioning and causing unnecessary costs to your infrastructure budget. But that's something that you can just abstract away and really focus on your application with. And one of the things that a lot of customers talk about is the upgrade process, right? With having virtual nodes, you can have the seamless upgrades of both the Kubernetes minor versions and OS upgrades. Those cluster components are coordinated, and customer workloads are not impacted. And one of the things that is of note is that from a cost perspective, you pay for the pods and not the computer infrastructure, right? So customers pay for the resources they use, and once again, you don't have to worry about paying for capacity headroom, and you really maximize utilization. Now, with that being said, managed nodes, we are kind of treating it as semi-managed, or some of that is abstracted away from you, as Mickey pointed out with the on-demand node pool upgrade feature. We are offering ways for both the virtual nodes and managed nodes to improve the experience with customers. Look to have that flexibility and agility in their based on their workloads, right? So with virtual nodes, we look at that as a way for customers really to move away from infrastructure and have that agility, and then managed nodes kind of pulling that lever to the left, saying, hey, I want a little bit more control with some management features that can help me as part of the managing the infrastructure that I have to as part of my OKE cluster. So with that being said, we have another roadmap item coming up by the end of this month, or I'm sorry, end of May, where what we're calling self-managed nodes will be introduced as another node type on OKE. And self-managed nodes, sometimes internally we refer to it as bring your own nodes, will allow the capability of adding OCI compute instances or a pool of instances as part of the instance pool construct to OKE clusters. So essentially, if there's a OCI compute configuration that is something that you would like to use or have containerized workloads run on and add to your OKE cluster, this will now be possible, right? So these nodes are added, like I was mentioning, through the compute workflow and added to a cluster, right? So the trade-off might be that some of the management features with the managed nodes may not be available, but some of our customers are willing to trade that off to allow the need or enable use cases where they need that highly specialized compute configuration. For example, we have customers that are looking at using managed nodes and the GPU instances with those for AI use cases with inference, training models. But in that same application, they also have training models, ML training models that need more high performance computing, low latency, but they still want it containerized and used on OKE. So that's where they're going to be using RDMA enabled cluster networks, right? So like bare metal GPU shapes with that cluster network for the ultra low latency, high performance computing capability. And those same self-managed nodes will be part of the same cluster in this use case, right? So that really enables them to use OKE for different use cases and allowing more flexibility and more control, right? So as customers are there's quite a bit of savvy Kubernetes customers that we work with that really want that door open on, hey, I want to bring certain instances to my OKE cluster that may not be available as part of your NoPool API today, right? It may be in the future, but we don't want to be limited in that way to say, hey, these are the types of shapes and images that you can use. So this will really enable new use cases. We're excited to see how users and customers use this and what they bring and how this shapes our node strategy going forward. So that's upcoming. We recently announced a new feature called Kubernetes Workload Identity. And we realized that finding solutions to access cloud resources with the least amount of privilege can be challenges for a customer, especially with security and compliance teams mandating the least amount of privilege to run workloads on your cluster, right? So this feature now will offer that fine-grained identity and access management control. It allows you to grant Kubernetes pod policy-driven access to Oracle Cloud Infrastructure resources using OCI IAM, right? So that is now giving you that level of granularity that you can really enable multi-tenant type workload use cases. And just so we kind of level set here, what is a Kubernetes workload? We defined it as a application that runs on Kubernetes that can be comprised of a single component or several components that work together that run inside a set of pods, right? So associate every pod in a workload with the same Kubernetes service account, right? So that'll be what a Kubernetes workload is, and those pods will then be bound to a cluster role permission, and then that is granted access to the Kubernetes resources, and then this feature will enable you to grant the OCI resource permissions, right, as part of just using standard OCI policy configuration options. So, imagine that you have an application that needs to access a object storage bucket. Security team says you can't use secrets, right? So this feature will eliminate the need of you having to store secrets in your Kubernetes cluster. And it really enables, a lower total cost of ownership. And the way it can help with that is previously you would have to use instance principals would act as the actors as part of a NoPool group where you can essentially make sure pods that need to access certain resources are only scheduled to certain nodes. And what that may be causing is more nodes, more node pools, just for policy restriction, not necessarily to run additional workloads for compute horsepower. So we're actually seeing customers using this to actually reduce the total cost of ownership of their compute resources, in addition to enhancing their security posture. So we're excited about this feature as well moving forward. And another recent addition we have is preemptable worker nodes, right? So this is kind of equivalent to spot instances that you may be familiar with from other providers. On OCI, preemptable instances provide a 50% discount from the on-demand instance pricing. This is on-demand capacity is the capacity that you by default set your clusters up with. Like if you're going and creating, this is just the guaranteed capacity of a node. And this 50% discount, customers like it because it's a predicted amount that they can always be aware. be aware of. Like, it's not going to be something that's fluctuating. So customers like that they know exactly how much they're going to be saving. So that's a big plus that we're hearing from customers. The trade-off is that you really need to be ensuring that you have fault-tolerant workloads, workloads that can be interrupted to really take advantage of these lower availability guarantees. These could be use cases where you have like certain batch jobs, maybe dev test clusters, and that it's okay to have some. You can tolerate some of the interruptions there as well. So we were hearing a lot of customers that have use cases set up for this, and they were ready to take advantage of the cost savings, right? So we want to make sure this is available for those workloads. And it's important to note that this feature will allow you to continue to have like heterogeneous clusters where you have a mix of both on-demand and preemptible worker nodes. This is important for use cases where you need some level of a trade-off with the guarantee of capacity and the cost-saving preemptible capacity for certain types of workloads, right? So we made sure that you can take advantage of Kubernetes constructs such as labels, taints, and tolerations to ensure that the pods that you schedule go to the node of that it's designated for. So if you have like a batch job workload, you can ensure that those are going to the preemptible instances, and you potentially have a very stateful workload that's entering and data into a database that you don't want preemptible instances to be running those workloads. You can make sure that they're going to the on-demand worker nodes, right? So we recommend that you create separate node pools of, let's say, preemptible capacity and preemptible nodes along with the on-demand, but that's certainly going to be a capability that you can have moving forward. And with that, I'm going to quickly show a demo of seeing preemptible capacity on a OKE cluster. So as you can see, I have 3 clusters here, and this cluster right here has 2 node pools. And to my earlier comment, there's a on-demand, which is pool 1, and a preemptible node pool, which is pool 2. And as you can see, it has two worker nodes, right? I mean, total, but 1 for each node pool. But before I get to showing you what the nodes look like from Kubernetes perspective, if you wanted to create a preemptible instance or even on-demand instance, if you go, let's say you wanted to add a 3rd node pool, you can, here are the options as we saw a little bit earlier. One key thing here is within the placement configuration of your node, you pick one of the availability domains and the subnet for your node. And I'm going to leave the default for the fault domain. But here, this is the capacity type. So this is where you would choose, and by default, as I mentioned, it's set to on-demand, but you could set it to preemptible here to use that capacity type for the node that's created. And of note here is that if and when, I should say, that preemptible instance is reclaimed, you have the option of either permanently deleting the attached boot volume or actually saving it, right? So if you have a use case where you want to save the data, that's possible as well. And some of the actions are not going to be possible preemptible, and we can certainly look at documentation or send that to everyone just so you know what the limitations are. But yeah, that would are the main options. Now, one thing we do make sure is the shapes, not all shapes are supported on preemptible. And once again, that will be a list in the documentation. We made sure to filter the shapes that are supported. So as you can see, there's many virtual machine type shapes here. But we did add some, input validation. If a customer, let's say, chooses a VM shape, and actually, let's say they start out by choosing on-demand capacity, and they go and choose a bare metal shape, which is not supported by preemptible, and go try to change the capacity type, they should see a message, right? So this is just another indicator that you cannot choose this shape, a bare metal shape, with preemptible capacity. So that's just kind of some of the options that you see when you create the node pool with preemptible capacity. And I'm going to go to a cluster that has the one that I was showing earlier that has a worker node of both, like preemptible and on-demand. Okay, first I'm going to just show connection. I see there's 2 nodes, and if I were going to describe the nodes, there's some key points of metadata points here that are important for scheduling and what I was kind of talking about earlier. So this first node here shows a lot of the information with the on-demand. And of note here, there's no taints on this one, right? So we don't offer a taint for the on-demand capacity. And we don't offer a special label as well. Now, why I mentioned that, we do have the instance type labels, right? So you definitely have a lot of options here to schedule workloads to use these labels here. But above it, you'll see that we have the other one, the other node pool with the preemptible instance that has a taint. So you can certainly make use of this with using this taint and having a toleration for it if you have, let's say, that batch job workload that needs to go to this specific preemptible instance. And in addition, we do have a label as well to make sure that you can use that as for your scheduling purposes as well. So we have the preemptible node pool, and then we have the preemptible label as well.
All right. So we put together some FAQs for folks about, why enhanced clusters versus why basic clusters. So our hope ultimately is that enhanced clusters have such a large number of great new features that everyone will want to move on to them. We are really treating them as kind of the new standard for OKE. Our basic clusters, or existing type of clusters, are still available for use. There's still, zero control plane fee, but the idea is that we want people to recognize that, that control plane fee is pretty negligible, and I'll talk about that again in a second. And that shouldn't be a blocker for people to upgrade from one to the other. So why should you upgrade? You should upgrade for access to additional features. This is actually going to simplify your operational experience to the extent that it's going to lower your total cost of ownership. We're not forcing anybody to upgrade. You can continue to use basic clusters as they are today. All clusters will continue to receive core Kubernetes updates, like access to the new versions as they come out, security improvements, access to other types of shapes that are newly supported. If you don't upgrade, again, nothing changes. You can still create the same clusters that you have today. Essentially, the biggest difference is just going to be access to those features. So again, people have been upgrading their nodes for the last 4 years, 5 years. So that's not going to be removed. You're just going to have to continue doing that work yourself instead of leveraging these new features. And the nice thing about the change from basic to enhanced clusters is that there are no application changes required. This is just enabling new features. So all you're really doing is getting access to additional API calls, and there's no changes needed to your applications. A common question and a good question is, what is the additional control plane cost? So enhanced clusters just have a management fee of 10 cents per cluster per hour. It's the same cost you'll see from basically every other major managed Kubernetes provider. And again, the idea of these features is that by using virtual nodes, by using node cycling, you'll actually be able to lower your total cost of ownership through resource optimization and by removing management tasks. Another thing that's worth calling out is that just by virtue of running on OCI, and the fact that OCI has better price performance and also removes some costs related to network egress that you'll see from other providers, is that the TCO of running on OKE is already to 30 to 40% lower, and in some cases even higher than that, than it is on other providers. And the last thing to call out is just that there is an added data plane cost for virtual nodes in particular, but this is pretty negligible. It's just a management fee of not 15 cents per node per hour, but 1.5 cents per node per hour. So, and then also, of course, the underlying container instance resources as well. Cool. So with that, we do have a few poll questions for you that we'd love to get your feedback on. I know there are also a couple questions in the Q&A.
Thank you all so much for joining us here today. We really appreciate it, and we hope to see you again next time.